method do you like most?
Sorry, sir.
Which method you are interested most?
Electrical method.
Electrical method. Okay, good. So, which physical principles we use in the electrical method?
We are using Ohm's law.
Ohm's law. Okay. What is Ohm's law?
Ohm's law is defined as current density at a particular point in a conducting medium is directly proportional to the electric field at that point in a medium. It is J equals to sigma E. J is the current density, sigma is the conductivity, and E is the electric field.
Okay. Any other form of Ohm's law? Do you know?
Yeah, V equals to IR.
IR. Where R is
R is the resistance of the medium.
resistance of the medium. Okay, good. So, what is resistance basically, if you define it?
We can say that resistance is the opposition to the flow of current in any medium.
Okay. And what is resistivity?
Resistivity is the fundamental property of a material which is constant for a particular material, and it defines the ability to oppose the flow of current, ability to
Okay.
resist the current. Yeah.
Okay, good. And what is the basic fundamental difference between resistivity and resistance?
Resistance is the opposition provided to the flow of current, but resistivity is the ability of a material to the flow of current. Basic difference. I'm not able to recall it right now.
Okay, let's say you have a wire of length L
Okay.
and you just double the length of wire. So which one will change, resistivity or resistance?
Resistance will change because it depends upon the dimensions of the material, but resistivity won't change.
Okay, and if we increase the temperature surrounding the wire, then which resistance or resistivity effect?
Resistivity will change then.
Resistivity will be affected. And what about the resistance?
Resistance won't change.
Won't affect. Are you sure?
Yeah, I'm sure.
Okay, okay. And what is conductivity?
Conductivity is ability to conduct the electricity or to the ability to allow the flow of electrons in a medium.
Okay, okay, good. And there is a term we use, dielectric constant, right? So what is the dielectric constant and what is its value for the water?
Its value for water is approximately 80.
Okay. And how will you define the dielectric constant?
I'm not able to recall it right now.
Okay,
Proper.
no problem. Do you know permittivity? What is permittivity?
It is also a constant, silent,
Okay.
and it is the
Okay, there are three terms. Let's say one is permeability, another one is permittivity, and next is dielectric constant. Okay. And you have to differentiate between them. The first point must be the definition. So can you tell me the proper definition of these three?
okay. I'll try to
Yeah,
get
sure.
it. Dielectric constant is basically the ratio of the permittivity of the medium to that of the free space.
Okay, that means the relative permittivity you are talking.
Yes.
Okay, good.
And permittivity Permeability is somehow dependent upon the, sorry, I don't know the definitions for these things.
Okay, okay, no problem. Okay, which methods we use in the electrical prospecting?
We use three methods: resistivity survey, SP methods, and IP methods.
Okay. What is the fundamental difference between these three?
In resistivity and IP methods, these two are the active methods in which we are basically inducing or injecting the current into the ground, and simultaneously we are recording the signals, or we can say the results. Whereas SP is a passive method which is occurring naturally inside the subsurface of the earth.
Okay, good. And what physical property we measure in resistivity method, self potential method, and induced polarization method?
In resistivity, we are measuring the resistivity itself. In
Okay.
IP met in SP method, we are in all three we are measuring the resistivity or conductivity.
Okay, good, good. And what is the induced polarization and how it is originated in the earth? Can you briefly describe it?
Yes. Induced polarization is inducing when we inject the controlled current into the ground. At that point, the built-in up voltage starts to build up, and then when that induced current is switched off, then the primary voltage which is being generated is it suddenly drops, not exactly to zero, but to a secondary level. Like we can say that it has secondary voltage, and then that transient voltage diminishes with time. So in this way, we are just uh, switching on the current or switching off the current, and we are measuring it depending upon our needs, whether it could be done in time domain method or it could be done in frequency domain.
In time domain, what we measure?
We measure chargeability.
Chargeability. How it is defined?
Chargeability, we can say that capacity to store the charges on the surface, or we can say that it is the area under the decay curve or the response curve, which is the ratio of the steady state voltages between two particular time intervals.
Okay. And what is the unit of chargeability?
It is millivolt per volt. I check.
Okay. You are saying in the volt,
Millivolt per volt. The
millivolt per volt. That means
yes.
finally what you will get. Any formula do you remember of chargeability?
It is the ratio of secondary voltage to that of primary voltage.
It is the ratio.
Yeah.
Okay, look at this. Okay, after the interview, look at this one. Okay, and in the
So
frequency domain, what we measure?
we are measuring the change in voltage with respect to the phase at a particular frequency.
Two terms we use when we talk about the frequency effect in induced polarization. Do you
Okay.
remember?
Yeah. One is frequency effect, and other is the metal vector.
Okay, good. And how you will define both of?
Frequency effect, we can say it is a parameter in a frequency domain IP method, which is measured, जब हम आईपी मेथड को दो डिफरेंट फ्रीक्वेंसीज पर जब हम apparent resistivity को मेजर करते हैं then we get the frequency effect. We can define it like as uh, a high the resistivity at a low frequency minus resistivity at high frequency divided by resistivity at the high frequency.
High frequency. Okay. And what will be the unit of frequency effect?
It will be unitless,
It
dimensionless.
will be unitless. Okay, good. And what about the metal factor?
Metal factor comes into account when we talk about the effective resistivity of the surface, and if, there is a factor like 2 pi into 10 to the power 5, and then resistivity at the low frequency minus resistivity at high frequency divided by multiplication of resistivity at the high frequency and the low frequency resistivity.
Okay. You said that we determine the effective resistivity, and you used a term apparent resistivity, right?
Yes, yes.
What is this,
Mm.
and
Effective
how it will be different with the actual resistivity?
Effective resistivity is a resistivity which we use when there are certain other factors, like uh, we are looking into what type of electrolyte we are using, what type of pore spaces are there. When there are different factors affecting the medium, in that case we use the effective resistivity.
Okay.
Sorry. And apparent resistivity, it is not a true resistivity, but it is not the true resistivity, but it comes into account जब हमारा मेजरमेंट बहुत सारे फैक्टर्स को इन्फ्लुएंस करें, लाइक कि हमारे पास इंस्ट्रूमेंट की वजह से एरर्स हो सकते हैं, ह्यूमन एरर्स हो सकते हैं, और हमारा सब सरफेस होमोजीनियस नहीं होगा, तो इन दैट केस वी यूज एपरेंट रेजिस्टिविटी. ट्रू
o-
रेजिस्टिविटी इज एन आइडियल केस.
Okay. And why we measure only apparent resistivity? Why can't we determine the true resistivity using this electrical method? Any reason for that specific reason?
अकॉर्डिंग टू मी, shall I guess it?
Yeah, sure.
हाँ, मतलब according to me, we are made because whatever we are studying is an ideal case. It is we are discussing it like there are no background noise, there are no instrumental errors, there are no human errors. But on field, the practical situation is something different, right? तो वहाँ पर हमारे पास inhomogeneity भी है सब surface की. हमारे से जो the labor we are using, it will also cause some errors. और हमारे पास एनवायरमेंटल फैक्टर्स भी हैं, इंस्ट्रूमेंट्स भी हमेशा परफेक्ट नहीं है कि वो उस पर्टिकुलर सिचुएशन में एकदम सही काम करे. तो दैट्स व्हाई हमारी जो एक्चुअल रेजिस्टिविटी की वैल्यू है वो हमें एक्चुअल नहीं मिल सकती है, तो दैट्स व्हाई वी आर मेजरिंग द एपरेंट रेजिस्टिविटी.
Okay. The same thing can be happen in the gravity and magnetic field also. Like the external effect can influence the gravimeter reading and magnetometer reading also. Then can we use the term effective gravity and effective magnetic field? We if we it, is that we use these terms or not?
I think we can use them, but we are focused much more on the density contrast in the gravity method and susceptibility contrast on the magnetic.
Okay, so is that we use the term effective density or apparent density in the gravity method? Okay, leave it. You said that we use the ideal condition. If we use the ideal condition, then we will get the true resistivity. What are these ideal conditions? Like what we assume the earth when we talk about the electrical method. What are the basic assumptions?
But is homogeneous surface we are assuming.
Okay, what does it mean by the homogeneous medium?
There are no, what can say, there are no, मतलब all over, there is a there is, we can say, uniform resistivity, say that.
What is the mean of term homogeneity?
Uniform density everywhere.
Okay, like physical properties are same,
Yeah.
uniform. Okay. And the one term we use the isotropic. What is
Yes.
that?
Isotopic is uh, in whatever direction we measure the certain properties, those properties won't change. We will get the same answer. That is known as isotopy.
Okay, you said that we use three methods in electrical prospecting. The one is resistivity, the another is self potential method, right?
Yes.
So can you tell me how this self potential is arise in the earth?
Arises. Basically, it arises due to it is having two origins, uh, mechanical origin and a man-made origin. In one, we can say there is a in one we can say there is a due to electrokinetic or electrochemical potential which arise.
You are using random terms like electromagnetic potential. Can you define it? Electrokinetic potential, what the term means actual?
Electrokinetic potential is uh, when uh, when we force a electrolyte to through a pass through a tube, then there is a potential generated between the ends of the tube. Uh, Basically, we can say it like a capillary action in a tube. So, in that case, electrokinetic potential arises, and electrochemical potential is it is a combination of two potentials, diffusion and the Nernst potential. Uh, in which Nernst potential arises when we insert a when we insert two. It arises when the two similar type of electrodes are inserted into a uh, into a uh, into the solution having different concentrations. But diffusion potential arises due to the potential differences between the mobilities of the anions and the cations. So the combination of these two potentials is known as electrochemical.
Okay, good. And do you know about the four probe method?
Are you talking about four electrode method, right?
No, four probe method. Have you heard the term?
No, sorry, sir.
Four electrode method?
Yeah, I have read it.
Okay, so there are various configurations we use, right?
Yes,
So what are the configurations? Can you briefly name them?
yes. One is Venner configuration, Schlumberger, dipole-dipole, pole-dipole, and pole-pole configurations we use.
What is the basic difference in these configurations?
In Venner configuration, the midpoint between the current and the potential electrodes is the same, and the distance between the adjacent electrodes is also same. In Schlumberger configuration, but in Schlumberger configuration, the midpoint between the electrodes is same, but the current electrode is placed at a far distance.
Any application of this Schlumberger configuration?
Yes. It is used for vertical electrical sounding vertical electrical sound.
Why we use it in vertical electric sounding method? Any specific reason for that?
Because we can say that the midpoint is fixed between the potential electrodes, well, between the two electrodes, the midpoint is fixed, and we keep on increasing the distance between the current electrodes. So that what happens? the current line starts to penetrate deeper inside the earth, and we will be able to read, we will be able to get the more information or knowledge about the what deeper inside the earth. That's why we use the sum measure configuration.
Very good. And if we have to do lateral profiling, which configuration we will use?
We will use Venner configuration.
Okay, any reason?
Yeah, Venner configuration is much more sensitive for the vertical variations. It is much more sensitive to the vertical variations, and for the shallow shallow depth we are using it. And by keep it is good in uh, giving the information about the information what's basically behind the configuration, या फिर जो array के नीचे जितना भी portion है उसकी अगर हमें एक particular information चाहिए, because the electrode spacing is short in the Venner array. अगर हमें particularly उस area की information चाहिए तो Venner array is much more suitable.
Okay, okay. And do you know the law of refraction?
In electrical method or in general?
Yeah, in general, law of refraction.
Yeah, law of refraction, it is defined by Snell's law, and it basically relates the refractive indices of the two medium when a ray passes from one medium to another, and it is termed as n1 sin theta 1 is equal to n2 sin theta 2.
Okay. And can we use it in electrical method also, in electrical analog?
Yeah, its electrical analog is rho 1 tan theta 1 is equals to rho 2 tan theta 2, where it relates the resistivities of the two medium.
Okay, good. And do you know the K factor?
Yeah, it is known as resistivity contrast, and it is defined like the difference between the resistivities. It is defined as the ratio of the difference between the resistivity of the lower medium to that of the upper medium, like rho 2 minus rho 1 divided by rho 2 plus rho 1, where rho 2 and rho 1 are the medium resistivity.
Why it is important in electrical surveying? Like
So
if we know the resistivity contrast, then what we can explain or what we can say about the structure?
So, through this, we could get to know that what type of different layers are behind the subsurface. That's why we use a resistivity contrast.
Okay, good, good. Okay, thank you, Arpita. Asudeep, you can continue.
Okay, thank you, Mohit. Okay, Arpita. Now how many type of material do you know based on the conductivity?
Three types of materials are there: conductors, insulators, and semiconductors.
What is the difference between these?
Conductors are basically which allow the flow of current, and inductors they never allow the movement of current, and they always oppose the flow of current. Or in semiconductors, their conductivity lies between both of them, and their conductivity can vary according to our needs.
Okay. Have you said inductors?
I have heard inductance.
Okay, okay. So what is the order of resistivity for conductors?
For conductors, it is greater than It is 10 to the power minus 5 ohm Siemens meter.
Okay. So, any good or body that you know? Can you example? Rock based on conductivity.
Sorry, can you repeat?
Any good conducting or body? Can you name any body or body?
Sulfide,
Okay. Any other? Any other?
oxides are also good conducting.
Okay. Oxide of which? Okay. Suppose you have graphite and hematite. Hmm? So out of these two, which is the conductor? Good conductor.
Graphite is a good conductor.
And hematite is
Hematite is also a conductor, but its conductivity is low as comparison to graphite.
okay. So what are the major controlling factors of the conductivity?
Uh, Sorry, please repeat.
What are the major controlling factors of conductivity or resistivity?
Of any material, right?
Yes, yes.
It depends upon how many free electrons are present in a material,
Okay.
or it
Does
also
it
sorry,
continue?
if we talk about the subsurface, so it depends upon what type of electrolyte we are using. And if we're talking in general, so we can say that how many types of free electrons are present. So on that basis, we can define it.
Does it depend on temperature?
Yes, it depends upon temperature, right?
How?
For conductors, the conductivity decreases with increase in temperature. For
Why?
insulators,
Why?
why? Okay, for conductors, conductivity is basically defined like Ne square tau by m. When we increase the temperature, the movement between the electrons increases, due to which the relaxation time decreases, and in turn the conductivity also decreases.
Okay. So any other factors with respect to the rocks and minerals? Any other major controlling factor in the rocks which control the resistivity?
Groundwater plays a key role.
Okay. So is there any law related to that?
Archie's law, I think.
Okay, good. What is the Archie's law?
It relates the resistivity of the rocks to that of the to that of it relates the resistivity of the rock to that of the resistivity of the pore spaces in the solution.
Okay. So okay, you have used pore. What is porosity?
It is defined as the it is defined as the voids. It is defined as the voids or spaces in a mm, particular rock or particular medium. It is known as porosity.
Okay. So how many in general there are how many type of rocks?
Three types of rocks are there: igneous, sedimentary, and metamorphic.
Okay. So out of these three, which has the highest resistivity?
Igneous is having the highest resistivity
Why?
because they are more compact. There are They are more compact and
So you mean the
also metamorphic
compaction?
is also metamorphics are also highly resistant.
Okay. So okay. So can you name the electrical properties of the rocks and minerals? How many electrical properties do you know?
I am not able to recall it right.
Okay, no issue. So there is the self potential, electrical conductivity or resistivity, the permittivity. So out of which you think the most important property for the survey?
Please repeat. Let me write it.
Okay, so there is the conductivity, self
Okay.
potential,
Okay.
dielectric constant, and the magnetic permeability. Right.
Okay.
So out of these four, which is most important that you think?
For importance regarding
Electrical survey.
okay. Conductivity is most important regarding electrical survey because in the end we are trying to get conductivity or resistivity in the electrical survey.
Okay. Any other reason? Okay. Do you know the range of the conductivity for rocks and minerals?
For igneous or sedimentary rock or
Yes, sir. In general, a expected range of this resistivity.
for rock I know.
Okay. What is that?
For sedimentary rock it is 10 to 10 to the power 4 ohm meters, and for igneous and metamorphic rock it is approximately 10 to the power 3 to 10 to the power 7 ohm meters.
Okay. Good. So can you tell the resistive conductivity variation if you go from surface to the center of Earth? Can you draw the variation? Hello.
Yeah, like I'm saying, like,
Okay, just tell me this. It will decrease or increase
it will decrease.
the resistivity or conductivity.
Activity will decrease because as we go deeper inside the earth, the inner core is filled with uh, iron or materials. So and that's why I think that resistivity will decrease when we go deeper inside.
Okay, okay, good. Okay, what is polarization?
It is the ability of a material to acquire the charges on its surface.
Okay, so can you polarize any material?
Not any material. We can't polarize inductors.
Inductors. Okay, inductors or insulators.
Sorry, insulators. Sorry.
Okay, okay. So can we polarize conductors?
Conductors can be polarized
Okay,
and dielectric also.
okay, dielectric also. So what are the dielectrics? Can you example?
Example, sorry, I'm not able to recall it.
Okay, no issue. So, water is dielectric or not?
Sorry.
Water molecule.
Please repeat.
The water molecule, is it dielectric or not?
It is dielectric.
Okay. So, what is the dielectric constant for this?
Approximately 80.
Good, good. Have you heard about the polarization vector?
Yes, I have heard about it.
So, how will you define this polarization vector?
It is, I think, del D by del T.
Okay. So what is del P by here? These terms?
It is a it is a current displacement current vector.
Okay. What is the unit of this polarization vector?
It is per meter square. Sorry, I'm not able to recall it.
Okay, okay, no issue, no issue. Okay. So just tell me the two applications of the SP method.
It is used for the groundwater applications and the geothermal investigation.
Okay. And the what is limitation of this method?
Limitation is it is having a lower penetration depth. We can go approximately up to 30 to 60 meters deeper inside the earth, and the chances of cumulative errors are also there in this method.
Okay. So do you know about the leapfrog technique with respect to the self potential method?
Yes,
Okay, what is that?
basically, it is a self potential survey method in which there is a fixed electrode spacing, or we can say it is a gradient method in which we take two electrodes, in which the first one is known as the leading electrode and the next one is known as the trailing electrode, and we are keeping the distance between both the electrodes same. And after that, after measuring the potential difference between those two electrodes, we then again put the leading electrode next to the trailing electrode. In this way, we are just keep on measuring the potential differences between these two electrodes. This is known as leapfrog technique.
Okay, so what is the advantage of this technique?
It is good for where we need a short spacing. It is easy to use and uh, अन- हमें कम लेबर्स भी चाहिए होंगे अगर हमें ये टेक्निक करनी है तो.
Okay, good. So, Pita, what are your hobbies?
My hobbies are baking chocolates and playing badminton.
Okay. So, which is your favorite player in the badminton?
China,
Who is? Okay. Any other player?
PV Sindhu.
Okay. So, is it the badminton in the Olympics?
Yes, badminton is an Olympic.
And in the Asian Games,
Sorry, I don't know. I'll check.
okay, okay, no issue. Thank you, Arpita.
Thank you.
Okay. So, Arpita, you from Ghaziabad, Uttar Pradesh, right?
Yes, yes.
Okay. So, you have any idea about the any minerals? What are the important mineral which is found in your areas? You know,
Sorry, I need to go and check it out. I have not seen, matlab, I have not researched on it.
do you know any branch or have any branch of GSI in UP or not?
It is in Lucknow.
No. Lucknow is the capital of UP, right?
Yeah, Lucknow. Yes.
So, Arpita, first of all, tell me what is the difference between the minerals and rock?
Rock is basically it is the accumulation of minerals. It is rock is something that is made up from two or more minerals, we can say. But mineral, it is a same substance throughout.
Okay. You have any subdivision of minerals? You know, any idea?
Sorry, I don't have any idea about it.
Okay. So, tell me one example of non-metallic minerals.
Gold.
Non-metallic.
No, no, sorry, it is clay.
Clay, right? And
Uh,
okay. And example of and metallic minerals.
Iron, copper.
Yes, right. Okay. So, Arpita, tell me what is the application of resistivity method?
It is used for understanding the uh, understanding the resistivity layers or the geology of the subsurface, that what is the pattern of resistivity inside the earth, and
Any
and
other?
we can do a qualitative interpretation for these by looking at the curves. We can interpret the results of the geology, so it's not a much cumbersome process.
Okay. Any or?
Right now I'm able to recall these two only.
Okay. So, what is the basic principle of resistivity method?
It is Ohm's law.
What is Ohm's law?
Ohm's law is current density at a particular point in a conducting medium is directly proportional to the electric field at that in that medium. J equals to sigma E.
So, Ohm's law valid for conductor, the electrical insulator, all the materials.
Please repeat.
The Ohm's law valid for conductor or also valid for insulators, the electrical materials also.
सॉरी, आपकी आवाज थोड़ी सी कट रही है.
Okay. Yeah, I can repeat my question. The Ohm's law valid for only for conductor and is valid for insulator and electrical materials also.
Okay. Ohm's law is valid for conductors only, as
What
far
is
as I remember. Yeah.
what is the change for Ohm's law in a insulator and electrical? If you know.
For insulators, it is not applicable, but for semiconductors, to some extent, it shows the linear relation between I and V. So for some extent, we can say that it is applicable for semiconductors also, but it is not applicable for insulators.
Okay. And what is the difference between semiconductor and conductor?
In conductors, if we talk about the in conductors, there is no band gap between the valence band and the conduction band, whereas there is certain band gap between the valence band and the conduction band in case of semiconductors. And the second difference, we can say, the conductivity of semiconductors is low in comparison to the conductors. And thirdly, we can differentiate them on the basis of temperature also. The conductivity of conductor decreases with increase in the temperature, whereas for semiconductors, it will increase with increase in the temperature.
Okay. So tell me one example of P-type semiconductor and one example of N-type semiconductor.
N-type semiconductors are those in which we are inserting a pentavalent impurity. Uh, it is phosphorus,
Okay.
and for P-type, in which we are adding a for P-type, example is boron.
Boron.
Yeah.
So Arpita, in resistivity method, we use different instrument in field survey for measuring the resistivity. Do you know any which instrument we use?
Like you are talking about configurations or
No, no.
no?
I am. I repeat my question. In a resistivity method, we measure resistivity. So for
Right.
measuring resistivity, we use different instrument like in a field survey. So which type of instrument we use for measuring the resistivity?
At present, we are using. I think I am guessing it only. I think we are using Phoenix and Centric. uh, I don't know about it much.
So how to measure resistivity in field survey? Tell me simple configurations. How to measure?
Basically, we measure the. um, Suppose if we are having a certain rock sample, let me explain it by an example of measuring the resistivity of a simple rock. Okay. Suppose we have a certain rock and we want to measure the resistivity of that rock. So, we will induce the current. We will place that rock sample in between the potential electrodes, and then between the distance between the current and the potential electrodes, we will put some water medium, right? Then we start injecting the current. We are using water medium so that there is a smooth flow of current to minimize the contact resistance also. In that way, when we induce the current, the potential difference could be measured through the potential electrodes. In that way, we could have the ratio of V by I. So through that, we can get the resistivity.
Okay. So my question is that, I mean, for instrument like a current source, electrode, a voltmeter, ammeter, this type of instrument we use measuring the resistivity.
Okay,
What is
voltmeter, voltmeter.
yeah, voltmeter, current source, electrode, cables, we,
Okay, okay, okay.
and Arpita, tell me what is the difference between resistivity sounding and profiling?
Resistivity sounding is when the resistivity sounding is when the physical properties are measured, physical properties changes with respect to the depth. We can say it in the z direction. And for resistivity profiling, we can say when the physical properties changes within the horizontal area in the x direction, we can say. And we can also say that resistivity sounding is a complex process to handle, whereas resistivity profiling is comparatively easy task. And for
Okay.
resistivity sounding we could use Schlumberger array, and for resistivity profiling we could use Venner array.
Okay. So resistive sounding we use Lumber's array. If we use dipole array, so it is any advantage? Any specific reason why we are use Lumber's array?
Yeah, we are using Schlumberger array because the midpoint is fixed between the electrodes. So we are increasing the distance between the current electrodes. Because of that, we are able that current lines are penetrating deeper inside the earth, and we are able to know about more what is happening deep inside the earth. But if we talk about the dipole array, in which the distance between the a single pair of electrodes is same, but the distance between their midpoint is large. So in that case, that is not possible. Uh, that is not possible, I guess. That's why we can't use dipole array in case of sounding.
But dipole array depth of penetration very large compared to the Lumber's array.
But it is much more suitable for the horizontal variations, not for the vertical variations. It is insensitive to the vertical variations. Well, it gives poor resolution in that case. It
Yes,
is a
poor.
disadvantage.
Yes. Okay. Thank you, Arpita.
Thank you.
Sanu.
Hello.
Yes, sir.
Okay. Okay. Can you arrange the all the configuration in according to depth of investigation?
Okay, let me try.
Okay. First statement. What are the configuration? Name
Sorry, can you please repeat?
name the electrical resistivity configuration. Whatever we have.
Uh, Venner, Schlumberger, dipole, and pole dipole.
Okay. Now you can arrange the depth of investigation.
Mm, I think higher depth of penetration is for pole, and then dipole, then pole dipole, then Schlumberger, and then Venner array.
Okay. So what type of electrical conduction? Type of electrical conduction.
Uh, Three types of electrical conductions are there: electronic conduction, electrolytic conduction, and dielectric conduction. So, dielectric basically happens in case of insulators. Electrolytic conduction, it happens in the liquids, and electronic conduction in case of the conductors of metals.
Okay. How dielectric conduction happen in insulator? Any idea about it?
Sorry, I need to
Okay.
check it. Yeah.
Okay. No problem. Do you know the coefficient of anisotropy?
Sorry, sir.
Okay. Do you have any idea about the principle of equivalence and principle of suppression?
Yeah. Basically, these are the disadvantages of using resistivity methods. Uh, in principle of equivalence, basically it happens when we are taken into uh, principle of equivalence happens when we are taken about the characteristic curves of K and H type when a thin conducting layer is between the two resistive layers like a type H curve, or when we have a when we have a highly resistive layer in between the two conducting layers. In case of K curve, the apparent resistivity sounding values of both the cases will be same. So this is called as principle of equivalence. Whereas in case of principle of suppression, it happens in the case of type A and type Q curves. In type A curves, where we have a increasing order of resistivity as we go deeper inside the earth, and in case of type Q, it is having a decreasing order of apparent resistivity as we go deeper inside the earth. So in this case, if there is a thin layer, so we are not able to uh, in that if there is a thin layer in between, we are not able to demarcate it until and unless it is highly resistive. So these are the two principles: principle of suppression and equivalence.
Okay. As a resistivity depend on what which factor? Am I wrong?
Resistivity depends upon temperature.
Only temperature. Mainly resistivity depend on which factor?
Sorry, please repeat.
So you saw now the resistivity means its variation from, like, you said something that in basal it is vary from 10 to the power 2 to 10 to the power 4.
आपकी आवाज ना क्लियर नहीं आ रही है.
Now I am audible.
Yes, yes, yeah. Please say.
So you said now the basalt rock has resistivity from 10 to the power 2 to 10 to the power 7 something.
Yeah.
So why there is a difference in range? So why the basalt rock now not a fixed resistivity? Why we are getting a range? Because I have a question.
No, actually, I'm not able to get your question. Actually, your voice is overlapping. Either my internet connection is wrong or either yours, I think.
Now I am audible.
Yes.
I am asking that when we are saying that resistivity of a rock, so we are mentioning a range.
Okay. Yes.
So why we are mentioning a range, not a particular value?
Actually, I have read it somewhere, and also there is a reason that why I said that the resistivity in case of igneous and metamorphic is high, but in case of sedimentary it is low. Are you asking about this?
No, no.
No.
Means okay, that also from point, but when we are saying that the graphite have a resistivity something, so what is resistivity of water? Any
Resistivity.
range?
It is 10 ohm meter to 100 ohm meters. I guess. I guess. I'm not sure about it.
Okay, okay. Means I am asking that why we are mentioning that range. Okay,
I think
it's
these are
dependent.
the empirical calculated results. What I can see is that only.
Oh, okay. Next question is that what is the telluric current?
Telluric currents are the guided currents inside the subsurface that arises due to the thunderstorms or thunderstorms inside the earth.
Okay, only thunderstorm or any another factor. Main, what is the main driving force of the electrical current?
Sorry, I'm not able to recall it right.
Okay, okay, you will read about it. So how we are measuring the electrical current? Any idea?
Sorry.
Okay, okay, okay. No problem. So how we are measuring the potential of electrode? Means
Uh,
any formula we are using in measuring the potential of electrode, and that formula came from where?
mm,
I think you don't get my question. Means in whatever we are configuration using, so we are using in some form of formula to
huh.
calculate the resistivity. So that formula is based on
Yes,
means which law?
please repeat.
So potential of a single electrode, how we are calculating? If we are inserted one electrode in a ground at a
Okay,
some distance, what will be the potential? What is the formula? Do you know?
okay. Yeah, we are basically measuring by providing a single current electrode on the surface, and then through current density, E is equals to rho J, where E is related to the potential, and I think its value is rho I by 2 pi R, the potential we are measuring.
Yes, yes. That's I want.
Okay.
I think that's covered. Okay, that's from my side. I think all actual question are covered. Right. Okay, thank you.
Thank you.
Gauri,
Okay, Arpita.
Yes.
Can you differentiate between the different currents we use in the three electrical methods?
Sorry, I don't have any idea about it.
We give input right to the ground to measure the resistivity.
Sorry, please repeat.
We do give an input current to the
Okay.
ground.
Okay.
So, what is the sort of difference between the current we provide in the three different, that is SP method, IP method, and resistivity methods?
Okay, okay. In IP methods, we use the DC current. In resistivity, also we use the DC current or the low frequency AC current, we can say. And in SP, we do not inject any current inside the
Is,
ground.
is there any difference between the current we use in uh, resistivity method and IP method?
No, they both are same.
Okay. So have you heard of applying interrupted current in IP? How do we measure this um, polarization effect within the IP method?
Basically, in the IP method, we are just switching on or off the current for a certain time. The method is different from that of the resistivity method.
So
In
the current is interrupted, right?
yeah, the current is interrupted, right?
So why do you think this dipole-dipole configuration is important in IP method? Hello?
Yeah, yeah. Just give me a second. Because I think it is much more suitable for the Because in IP methods, basically, we are searching for the disseminated sulfide ores or disseminated ores in our area. So dipole gives the dipole dipole is a perfect configuration for the for the horizontal variations mm, for a particular area. That's why we are using dipole dipole for the IP method.
Okay, very good. Um, so can you describe the methodologies we use in IP method from starting to end?
Okay. Basically, IP method is that in which we induce the controlling current. Uh, we provide the controlled current to the ground, and then the built-in up voltage starts to build to a certain value, and then when we switch off that induced current, the primary voltage suddenly drops down, but it don't goes to zero. It don't, then we termed it as secondary voltage, and then that transient voltage starts to diminish with time, right? And then again this built-in up voltage starts, and this process happens and happens as we switch on or off the current. But depending upon our need, what we require to measure it, this process could happen in two ways: time domain or the frequency domain. In time domain, we are measuring the change in voltage with respect to time, whereas in the frequency domain, we are measuring the voltage change in the voltage with with respect to the phase at a particular frequency. In time domain method, we are measuring a parameter that is known as chargeability, but in frequency domain method, we are measuring two parameters, that is frequency effect and metal vector.
Okay, after measuring this,
After
what's
me,
the next year?
um, we are going to interpret the results, and after that, we will be able to get the resistivity and stuff.
Okay, can you recall the a map we used to build after we measure this parameter?
Please repeat once, please.
You name the map which we use to correlate the field value with theoretical value.
I think it is pseudo section, right?
Okay, okay. Okay, how can you differentiate between a conductor from a non-conductor in IP method? Which parameter show a significant variation and how?
Um, Chargeability. If there is a high chargeability, then there will be a low resistivity. It will indicate that a material is a conductor, and
Okay.
in opposite case, the indicates that it will. If there is a low chargeability, then high resistivity is there. So we can say that there is a high resistive material.
So how do this resistivity changes with the frequency?
Yeah,
Hello?
yeah. I'm not able to recall the exact relation between these two.
Okay. What is the equation for frequency effect?
Uh, mm, our frequency effect is mm, the difference between the apparent resistivity measured at the low frequency minus the apparent resistivity measured at the high frequency divided by the the resistivity measured at the high frequency.
Okay, so which one do you think is have the greater value? Resistivity measured at lower frequency or higher frequency?
Resistivity measured at lower frequency.
have higher resistivity.
will be low. Resistivity measured at lower frequency will have the high value.
Okay, okay. Um, can you tell me some applications of IP method?
Firstly, it is used for the methods where we can't use the resistivity survey, like to understand the geology for where there is a disseminated sulfide ores are present. This is the most advantageous method for this. And
Okay.
right now, I'm able to recall one only.
Okay. So, what are the different potentials we measure in ST?
Two types of potentials, electrokinetic and electrochemical potentials we are measuring.
Okay. Can you differentiate that?
Yeah, in electrokinetic potential is the potential difference when we force the electrolyte to pass through a pass through a tube. So there is a potential difference between the two ends of the tube, right? So basically, we can say it like a capillary action through a porous medium. So that potential difference arises due to the that potential difference is known as the electrokinetic potential. In case of electrochemical potential, it arises due, it is a combination of two potential, Nernst potential and the diffusion potential. Nernst potential arises when the two similar type of metal electrodes are inserted into the solution having a different concentration. Whereas in case of diffusion potential, it arises due to the potential difference between the mobilities of the cations and anions in a medium, and the combination of these is known as electrochemical.
Have you heard of mineralization potential?
Yes, so it arises due to the ore body. I think so.
Okay, of these three potential, which is most dominant?
Mineralization potential is most dominant.
Okay, so you first didn't said the mineralization potential while you classified, right?
Yeah, sorry, I forget it.
Okay, what is the nature of potential uh, we measured as mineralization potential?
Sorry, please repeat.
What is the nature of potential we measure? If we measure mineralization potential, it has a particular sign. Can you some
I think it is a negative SP anomalies we are getting in the mineralization potential.
okay? Can you give an example of a material which gives this mineralization?
Uh, it is pyrrhotite or pyrite.
Okay,
I'm guessing it only.
okay, okay. Um, so what's the nature of this streaming potential you measure? What is it negative or is it positive?
It is positive. I think so. I think
Okay,
it is positive.
okay, then okay, coming to this resistivity method, what is the parameter we are measuring or what is the parameter we are getting after vertical electrical sound? What are the features we get?
What are? Please repeat. Actually शायद मेरा इंटरनेट कनेक्शन खराब है इसलिए मेरे को दिक्कत हो रही है.
Okay, what are the feature? What is the feature? What are the features we get after we do vertical electrical sound?
Okay. We uh, we get firstly we get the law of refraction in case of the resistivity method, and secondly we get the resistivity contrast, and thirdly we could also get the characteristics of the curves, like ki how is the geology of a particular area. Basically these three features we are getting in case of vertical electrical.
What do you mean by geology term? What? Why are we using vertical electrical sounding? That's my question.
Why are we using vertical electrical sounding, right?
Hmm.
Uh,
To,
we
to
are using it to know more about the layers. Basically, we get the characteristics of the curves. Which layer is more resistive or least conducting or highly conducting. That's why we are using vertical electrical sounding.
Okay. That's it from my side. Thank you, Arpada.
Thank you.
So तो अर्पिता के लिए अभी अभी मोस्ट सर आप फीडबैक दे दो।
सॉरी, क्या?
हाँ अर्पिता, मोस्ट ऑफ इंटरव्यू आपका अच्छा था,
ओके,
कम्युनिकेशन स्किल्स भी अच्छा है और ऐसा भी नहीं लग रहा कि कहीं पे कॉन्फिडेंस की कमी है। आई थिंक बेस्ट है।
थैंक यू।
राइट,
मतलब नर्वसनेस तो नहीं लगी, क्योंकि लास्ट इंटरव्यू में
नहीं
मेरे लिए यही सजेशन था।
नर्वसनेस नहीं लगा।
ओके,
हाँ। और एक क्वेश्चन जैसे गौरी ने पूछा ना, इंड्यूस पोलराइजेशन मेथड को एक्सप्लेन करो, मतलब थोड़ा बताओ उसके बारे में, तो आपने
ओके,
पूरा एक्सप्लेन कर दिया ना, मेटल फैक्टर और ये सब पूरा। तो थोड़ा सा उसको ब्रीफ में रखना ज्यादा बेटर रहेगा, क्योंकि उन्होंने आपने आंसर दिया, फिर वो पूछेंगे आपसे कि मेटल फैक्टर बताओ, ये बताओ, वो बताओ ना, तो
ओके,
ज्यादा बेटर रहेगा।
ठीक
खुद
है।
से हाँ, इतना ज्यादा खुद से बताने के बजाय थोड़ा शॉर्ट में रखो। कुछ चीजें जो चीजें अपने को आती है वो ऐसे रखो कि इंटरव्यूअर नेक्स्ट क्वेश्चन वही पूछे तो हम उसका आंसर दे देना, ऐसा कुछ।
ओके,
बाकी अच्छा है, काफी अच्छा है।
थैंक यू सो मच।
ओके, अंशुदी, व्हाट डू यू थिंक?
Yes, Arpita, overall interview was good. Communication, confidence, representation. But हाँ, जो मोहित ने बोला वही कि sometimes you are going जिसकी जरूरत नहीं है बोलने की, क्योंकि कुछ तो उन्हें भी पूछना है फिर, और ज्यादा बोलोगे तो डेफिनेटली इशू आएगा कि कुछ ना कुछ ऐसे वर्ड निकलेंगे
ओके,
कि हाँ. And one thing is that like in my case you are using word the in the um, insulator, not using inductor, you are using the inductor
या
instead
वो
of the
यस,
insulator, और वो आप रिपीट ही कर रहे थे बार बार, सो इन चीजों का थोड़ा ध्यान रखो।
ओके, ओके,
बाकी सब अच्छा है।
थैंक यू।
ओके, सानू।
Yes, Arpita, your interview is very good, and I think all they are mentioned that your communication and your presentation is good, and knowledge also you're good. And whatever I asked that the rock, whatever the rock range, I'm asking that question. So it
यस,
is mainly we are not getting pure form of rock na. So some in there is any mineral, any accumulation of mineral or anything. That's why, and it's given other factor also, porosity and temperature also. So that's why we are some getting a range. We are not getting a perfect value.
ओके,
And I ask about that monitoring. You know that you will read it in Lori. So other question are correct, and I think you did very good interview and keep it up.
थैंक
Okay.
यू, थैंक
ओके, एंड गौरी।
Your presentation was very nice. Your confidence level was also good. You answered almost every question correctly. That's it.
थैंक यू।
Uh, what Mohit said. You just want to brief it.
ओके,
Just
ओके,
what are you measuring? What are you mapping? Then what you will do? Or like.
ओके, ओके, आई विल टेक केयर ऑफ इट।
यस अर्पिता, आपका इंटरव्यू ओवरऑल बहुत अच्छा था। कॉन्फिडेंस की बात करें, सब कुछ अच्छा था, और उन पे थोड़ा
आपकी आवाज साफ नहीं आ रही है।
आ रहा है आवाज।
हाँ,
हेलो।
अब आप क्लियर हो, अब वो आप, हाँ।
यस, हाँ अर्पिता, आपका इंटरव्यू बहुत अच्छा था। कॉन्फिडेंस, डेप्थ ऑफ इंफॉर्मेशन से बस सब चीजें अच्छी थी। और मोहित सर और जो अंशुदीप जो भी बोल रहे हैं उसके रिगार्डिंग कुछ थोड़ा, अदरवाइज ऑल ओवर इंटरव्यू वेरी गुड।
थैंक यू, आई विल टेक केयर ऑफ इट फॉर श्योर।
ओके।
ठीक है।
Okay. Okay, one thing I would like to add there, can we अपन जो ग्रुप डिस्कशन वाला सेशन है इसको थोड़ा सा एडवांस लेवल पे लेके चले क्या? जैसे ही अपने टॉपिक सारे खत्म हो जाते हैं उसके बाद हम क्या करते हैं कि जैसे अर्पिता का इंटरव्यू है तो एक चेयर लेके अर्पिता बैठेंगे जैसे अपना नॉर्मल यूपीएससी के इंटरव्यू रूम में होता है। एंड देन जो इंटरव्यू पूछेगा, क्वेश्चन पूछेगा, वो भी अपना कैमरा ऑन रखेगा और अर्पिता भी अपना कैमरा ऑन रखेंगे। उससे क्या होगा, अपन सब्जेक्ट के अलावा जो बॉडी लैंग्वेज है उसके अंदर भी कुछ सजेशंस दे पाएंगे बेटर।
इट्स अ गुड आइडिया।
Yes, Mohit. Will sure.
सिर्फ हम बोलने वाली हेजिटेशन हटा रहे हैं, बट मे बी बॉडी लैंग्वेज किसी के जेस्चर्स बहुत ज्यादा खराब हो तो ये भी एक फर्क पड़ेगा। एग्जैक्टली राइट।
अभी अपने और कौन से टॉपिक्स रह गए?